We are the product of stardust that has burned us using oxygen. Light is the anvil which forged me, which gave the will to make me formable for my misfits, because I will not break under force. All living things are electric and magnetic, and they use the electromagnetic radiation of the sun and the Earth's magnetic field to create life. Man-made radiation disrupts the natural order of atoms in our cells. The electromagnetic signals that come from the organization of these cells in mDNA creates our health span or chronic diseases epidemics. This is plants and animals. Humans are diurnal animals who need sunlight and darkness after sunset to function. This makes them fully decentralized. They cannot be optimal with too much of either. Indoor living, sun avoidance, constant exposure to artificial lights, and man-made electromagnetic radiation equals a shifted metabolism from light that leads to all chronic diseases. Optimizing melatonin, dopamine and melatonin, sunlight/darkness, and solar-derived vitamin D, melanin, and NO is how you avoid chronic disease. Point 2. Life as electric and magnetic. The stellar and terrestrial forge my assertion that all living things are electric and magnetic, aligns with the decentralized photobioelectric framework I've been building for 20 years, stardust and oxygen. The elements forming us, carbon, hydrogen, oxygen, nitrogen, originated in stars via nucleosynthesis, later dispersed by supernovae. Oxygen became abundant after the GOE 2.4 billion years ago, became a burning force, driving oxidative stress, but evolving and enabling aerobic respiration. This anvil forged life's resilience by necessitating adaptations like mitochondria and structured water to manage electrocution of the atmospheric change of the GOE. 3. Sunlight and Earth's magnetic field. The sun's electromagnetic radiation, UV, visible, IR, and Earth's magnetic field, e.g. 65 microteslas, provide the energy and orientation for life. Sunlight structures water. Maewon-Ho's liquid crystalline model, Pollak's easy water, induces charge separation, our electron flood, and triggers the dynamical Casimir effect, DCE, to generate biophotons from zero-point energy, ZP, right before endosymbiosis. These two effects assisted the electrical merger of bacteria and archaea. The magnetic field aligns cellular processes, potentially enhancing electron flow and biophoton coherence, facilitating a new evolutionary path. 4. Mitochondrial electromagnetic signals. The inner mitochondrial membrane, IMM, S30 to 40 MV/M field, Nick Lane, modulates biophoton emission from mDNA, as I've argued. These signals, amplified by vibrations and solitons from light-induced resistance, coordinate metabolism, health span, or disease states across plants, animals, and humans. 5. Man-made radiation disrupting the natural order. Man-made electromagnetic radiation, NEMF, e.g. from artificial lights, ALAN, Wi-Fi, cell towers, disrupts this natural order mechanism. NEMF alters atomic and molecular structures by inducing chaotic oscillations in water and biomolecules, breaking Ho's quantum coherence. This dehydrates cells, increasing NaCl conductivity, as we've noted, damages heme proteins, e.g., cytochrome C, and collapses the IMM's field, spiking our S/RNS, my self-electrocution hypothesis. 6. Chronic disease link. This disruption shifts metabolism, as you've said, leading to epidemics like diabetes, cancer, and neurodegenerative diseases. Ho's work on NEMF breaking biophoton signaling supports this, and the MAHA is HAHA movement ties our S/RNS spikes to acute disease. Contrast with natural radiation, sunlight and Earth's magnetic field are rhythmic and balanced, optimizing cellular function. NEMF's constant, non-native frequencies, e.g., 60 Hz, gigahertz, override this rhythm. 7. Light-dark cycle. Humans evolved under a 24-hour cycle, sunlight for energy and darkness for repair. Too much light, ALAN, or too little, Indoor living sun avoidance disrupts circadian rhythms, affecting mDNA signaling and metabolism and the biophoton spectra, which determines disease phenotype via heteroplasmy ratios. Decentralized nature. I highlight that humans are fully decentralized. Their health depends on individual alignment with natural cycles, not centralized control of biopharma, big tech, or big food under the umbrella of big government. This resonates with my photobioelectric model's emphasis on local bioelectric and electromechanical signals, e.g., solitons, biophotons. Metabolic shift. Indoor living and NMF exposure skew metabolism away from light-driven processes, e.g., OXPHOS, vitamin D synthesis, NO, favoring oxidative stress and inflammation, and cellular chaos leading to disease. Point 8. Melatonin. Produced by mDNA in darkness, melatonin regulates circadian rhythms and acts as a potent antioxidant, neutralizing RS/RNS. Sunlight exposure during the day creates melatonin, and darkness and a drop of temperature of CSF pathways enhances its nighttime surge, while alan suppresses it, disrupting sleep and mDNA repair, and this destroys all heme-based proteins equals cytochromes and NO synthetase, which creates NO to lower BP and controls the stem cell depots in humans needed for Becker's regeneration programs in most organs. Dopamine. Sunlight boosts dopamine synthesis in the brain via retinal light exposure, enhancing mood and motivation. NMF and light deficiency reduce dopamine, linking to depression and metabolic dysfunction. Melanin degradation by the effects of blue light and dehydration also create L-DOPA. Vitamin D. Synthesized in the skin from UV light, vitamin D regulates gene expression, immune function, and mitochondrial health. Sun avoidance and indoor living lower levels, increasing chronic disease risk, e.g., autoimmune disorders. Melanin. As I've emphasized, melanin absorbs sunlight, splits water to release electrons, and generates the bioelectric current that is 1/1,000,000th of 1 ampere. Becker found in his bone regeneration experiments. This supports the electron flood, neutralizes OH, and protects against NMF damage. Sun avoidance reduces melanin's counterintuitive protective role in all amphibian, reptilian, and mammal regeneration programs. Nitric oxide. NO UV light triggers NO release from skin stores, improving blood flow and reducing inflammation. NO also controls the flow of stem organs used to regenerate with the bioelectric currents. NMF and alan impair this, contributing to cardiovascular issues and organ failure. Optimizing these, via balanced sunlight exposure, darkness, and grounding, aligns mDNA signaling with natural electromagnetic cycles, enhancing health span and preventing chronic disease. 9. Stardust and oxygen. Life's electric magnetic nature stems from stellar elements, with oxygen, post-GE, forging resilience via mitochondrial water production, higher in bacteria, as I have discussed in blogs, and mDNA biophoton signaling. Light as the anvil. Sunlight structures water, triggers DC for ZP-derived biophotons, and induces vibrations/solitons via resistance, driving photobioelectric and electromechanical work. Earth's magnetic field aligns this process. NMF disruption. Man-made radiation breaks coherence, dehydrates cells, and spikes RS/RNS, shifting metabolism to disease states. mDNA signals reflect this imbalance, determining health span or chronicity. Diurnal optimization. Sunlight-darkness cycles regulate melatonin, dopamine, vitamin D, melanin, and NO, decentralizing health. Indoor living and NMF reverse this, necessitating natural exposure for resilience. Physiological work. Biophotons and solitons, amplified by ZP/DC, power ATP synthesis, ion fluxes, and cellular coordination with water, DDW, insulating the IMM's field. 10. How light becomes a bioelectric and electromechanical signal, a vibration light, as electromagnetic radiation, carries energy in the form of photons. When these photons interact with biomolecules, They can induce electrical and mechanical effects through absorption, scattering, or quantum interactions. Here's the process step by step. Photon absorption by biomolecules. Biomolecules like chromophores, e.g., cytochrome C oxidase in mitochondria, melanin in skin, or chlorophyll in photosynthetic organisms, absorb photons at specific wavelengths. For example, cytochrome C oxidase, CCO, absorbs red and near-infrared light, 600 to 1000 nanometers, exciting its electrons to higher energy states. This excitation creates a temporary dipole moment or charge separation within the molecule, generating a local electric field. This is the bioelectric signal. Light induces a voltage or current by altering the molecule's charge distribution. 11. Electrical resistance and signal propagation. The induced electric field encounters resistance from the biomolecule's structure and its surrounding environment, e.g., water, lipids, proteins. Resistance arises from the molecule's dielectric properties and the medium's impedance to charge flow. In mitochondria, the inner mitochondrial membrane, IMM, with its 30 to 40 MV/m field per Nick lane, already sustains a voltage, 150 to 200 MV. Light-induced charge separation in CCO could modulate this field, creating a bioelectric signal that propagates along the membrane or through structured water, per Ho's liquid crystalline model. Mechanical resistance and vibration. Light absorption can also induce mechanical effects. When a photon excites a biomolecule, it may cause conformational changes, e.g., CCO's heme group shifts during electron transfer, or melanin's conjugated structure vibrates upon absorbing light, per Herrera's water-splitting hypothesis. These conformational changes encounter mechanical resistance from the molecule's bonds and the surrounding medium, e.g., water, cytoskeleton. This resistance converts light energy into vibrational energy, manifesting as molecular oscillations or phonons, quanta of vibrational energy. 12. Soliton formation. I've mentioned that light hitting a biomolecule creates a soliton, a self-reinforcing, localized wave that travels without dissipating. In biological systems, solitons are hypothesized to arise from nonlinear interactions between vibrational energy, phonons, and the biomolecule structure. For example, Davidoff's soliton theory, 1973, suggests that vibrational energy in proteins, e.g., alpha helices, couples with lattice deformations, forming a soliton that propagates energy along the protein. Light-induced vibrations in a biomolecule could initiate such a soliton, transmitting energy and information across the cell, along microtubules or mitochondrial membranes. 13. Photon generation. Biophotons. I've noted that some of the things it hits become photons. This ties directly to the DC and aquaphotomics. When light-induced vibrations oscillate water molecules, acting as a mirror, the DC converts virtual photons from ZP into real biophotons. As I've discussed in earlier blogs, these biophotons, emitted by mDNA or water, per host coherence data, become a secondary signaling mechanism. They can stimulate other chromophores, propagate the bioelectric signal, or drive further vibrational effects, creating a feedback loop for energy and information transfer. Light becomes a vibration. The role of resistance. I've pinpointed resistance as the key to transforming light into vibrations. Electrical resistance. When light induces a bioelectric signal, e.g., charge separation in CCO, the signal encounters resistance from the biomolecule and its environment. This resistance converts some of the light's energy into heat or vibrational energy, phonons, as electrons collide with molecular structures. 14. Mechanical resistance. The biomolecule's conformational changes, e.g., stretching, bending, face mechanical resistance from bonds and the surrounding medium. This resistance dissipates energy as vibrations, which can couple with water or protein structures to form solitons. Vibration as a signal. These vibrations aren't random, they're coherent, as Ho's work suggests. In mitochondria, Vibrations in the IMM or matrix water could modulate biophoton emission, creating a light vibration feedback loop that sculpts life, as I've described. Role of ZP and DCE in this process: the ZP and DCE amplify this light-to-vibration transformation and its signaling potential. 15. ZP contribution. ZP provides a quantum energy reservoir via vacuum fluctuations. The DCE, triggered by water's oscillations, aquaphotometric mirror, converts ZP's virtual photons into real biophotons. These biophotons can enhance the initial light signal by stimulating chromophores, amplifying the bioelectric effect. Drive additional vibrations by exciting biomolecules, feeding into soliton formation. DCE as a signal amplifier. Water's aquaphotometric oscillations, driven by light, IMM fields, or thermal motion, generate biophotons via the DCE. These biophotons act as a secondary light source, reinforcing the photo, bioelectric, and electromechanical signals. This aligns with my idea of signaling and transmitting energy and information. 16. Physiological work via bioelectric and electromechanical signals. The bioelectric and electromechanical signals, now amplified by ZP and DCE, perform physiological work. This was likely active at endosymbiosis. Bioelectric work, the voltage induced by light, e.g. in CCO, can drive ion fluxes across membranes, power ATP synthesis via the IMM's proton motive force, or trigger signaling cascades, e.g. calcium waves in cells. In mitochondria, this enhances OXPHOS, producing ATP, water, and CO2. 17. Electromechanical work. Vibrations and solitons transmit energy mechanically. For example, solitons along microtubules, per Stewart-Hameroff's ORCHOR theory, could influence cytoskeletal dynamics, cell division, or mitochondrial positioning. In my cephalopod analogy, these vibrations might underlie chromatophore activity, linking their light release in their neural lessons to their metabolism to visible light signals. We know light controls metabolism this way already. Biochemists just act like these papers are not published, yet they are discoverable. 18. Information transfer. Biophotons and solitons encode information. Biophotons, with their coherence, HO, signal metabolic state across the cell, while solitons transmit localized energy packets, coordinating processes like protein folding or membrane dynamics. This is how light can create prion and protein misfolding in neurodegeneration. Tying to bacterial versus archaeal water production, my previous discussion on water production is relevant here for endosymbiosis. Bacteria, aerobic bacteria produce more water via O2 reduction, e.g., 12 H2O per glucose in the ETC. This water, potentially DDW, enhances aquaphotomic oscillations and DCE activity, amplifying biophoton generation from ZP. More water might mean stronger soliton formation as vibrations propagate through a larger structured water network. This energy likely helped fusion. Archaea, e.g., methanogens, produce less water, e.g., 2 H2O per CO2. With less water, their DCE and ZP utilization might be weaker, potentially limiting soliton and biophoton signaling. However, extremophile archaea might compensate with unique lipids or proteins that enhance vibrational coherence. This is why the mitochondrial backbone is mostly bacterial with archaeal components.